Now we're going to see how the distributive property works with variable expressions. So our first example, 3 times 4x plus 2. What I'd like for you guys to notice is if we were to follow the order of operations, we would be in an impasse. See, what I really have in here, if I write this out in a little bit more detail, I'm just going to write what's in the parentheses, is 4 times the number x plus 2. The order of operations says multiplication comes before addition, so I have to multiply 4 by x first. And this, of course, is where I get stuck. If you remember, when we talked about evaluating expressions, I don't know what 4 times x is because I don't know the value of x. And so if I was following the order of operations, I would say, well, I can't multiply 4 by x. That means I never get to add 2 because that has to happen after. I can't simplify this expression. The expression stays as is. However, if I use the distributive property, it lets me bypass this a little bit and lets me just say, forget about what's going on inside the parentheses. I can just multiply 3 into each term. 3 times 4x plus 3 times 2. Okay, well now I can actually do something. 3 times 4x, well 3 times 4 is 12, so 12x plus 3 times 2 is 6, so we get 12x plus 6. Notice that here I could multiply 3 by 4. The 4 is not really attached to the x that hard, because what you really have is 3 times 4 times x. Here, your operations are all multiplication, and the order doesn't matter. Nothing's preventing us to do 3 times 4 first, and then worry about the x later. And by the way, 12x plus 6 is our final answer, because just like I described earlier with the 4x plus 2, there's no way for me to multiply 12 by x, so I never get to add 6 to anything. I'm really done here. This is as simple as my expression is going to get. Let's take a look at the next example. 3x minus 1 times 6. Remember that it doesn't matter whether 6 is in the front or in the back because it's multiplication and the order doesn't matter. So we can distribute 6 times 3x minus 6 times 1. And remember, I can multiply 6 by 3 here. That will give me 18x. The x is still there. Minus 6 times 1 is 6. Final answer, 18x minus 6. Again, the same thing as the previous example, only this time we had a subtraction, which is perfectly fine because I am allowed to distribute multiplication over subtraction. Next example, -7 times 5x plus y minus 8. It doesn't really matter if I'm adding or subtracting 2 terms or 3 terms or 7 terms, as long as the operations inside the parentheses are adding and subtracting, and we are multiplying or dividing the whole thing, we are allowed to distribute. So we will distribute the multiplication over this addition and subtraction. That means that I'm multiplying the -7 by 5x, and I'm multiplying -7 by y. Now, I am also multiplying -7 by -8. And one little trick that you could use is you could just say negative times negative is positive and not worry about the minus signs. Just know you're going to end up with addition. But for now, I'll write it all out in detail. And so our answer is -7 times 5, which is -35. Don't forget we still have that x. -7 times y is -7y. So we can just say minus 7y, and then negative times negative is positive. 7 times 8 is 56, so plus 56, and there is our final answer, -35x minus 7y plus 56. Next example, -4m minus 11. There are many ways to think about this expression, but the easiest way is probably to think about it as there being a 1 in front of the parentheses, so you have kind of a -1 times 4m minus 11. The reason why you can do that is you know that 1 times any number is just that number. So if you insert a multiplication by 1, you're not going to change the value of the expression. It just gives you a number that you can use to multiply. Things make sense. And again, we distribute -1 times 4m plus -1 times -11. Negative times positive is negative, so that's minus 4m. And -1 times -11 is plus 11. Notice that basically what happened is the 4 was positive, and at the end, in the answer, it's negative. The 11 was negative, and it became positive. That's what putting a minus in front of the parenthesis does. It pretty much just changes all the signs in your expression. Okay, one more example. 18x minus 30 divided by 3. In this case, we have subtraction and division is going to be distributed over it. Again, I can't really do 18x minus 30 because I don't know what x equals, but I can certainly distribute 18x divided by 3 minus 30 divided by 3. And 18 divided by 3 is 6, so that's just 6. Don't forget the x. Minus 30 over 3 is 10. Answer is 6x minus 10. And so these examples illustrate how distributive property can be used to distribute multiplication or division over addition and subtraction. And you see that when we have variables in the picture, suddenly you can't follow the regular order of operations. I can't do the subtraction first and then everything else. So the distributive property becomes a very useful tool. So in this video, in the previous one, we talked about the things that you can do with the distributive property. And in the next video, we're going to talk about some of the things that you are not allowed to do.